Today we're going to talk about solving nonlinear systems of equations by substitution. By the end of this video, you'll be able to solve a linear quadratic system of two equations and a quadratic system of two equations by substitution. So let's start with a review problem. This is a system of two linear equations. You should have seen problems like this in Algebra 1, and we're going to solve by substitution. So that means we're going to take one equation, solve for either x or y, and then plug that into the other equation. So I'm going to start with the second equation and I'm going to solve it for y. So I'm going to start by subtracting 3x from both sides. Then I'm going to divide by -1. So now I have that y equals 3x plus 5. So I'm going to take 3x plus 5 and plug it in for y in the first equation. So my first equation is 4x minus 3 times y. So I'm going to plug 3x plus 5 in for y equals -5. Then we can just go ahead and solve. So we need to distribute the -3, so we get -9x minus 15. Then we're going to solve like normal, so I'm going to combine the two x terms, add 15 to both sides, and then divide by -5. So I get that x is 2. But I also need to solve for y. So I'm going to go back, and I'm going to use this equation here, y equals 3x plus 5, and I'm going to plug -2 in for x. So I have y equals 3 times -2 plus 5. So 3 times -2 is -6, plus 5 is -1. When you write your final answer, you should always write them as ordered pairs. When you write your final answer, you should always write it as an ordered pair. So I have the point -2, -1 as my final answer. And then there are several ways you can check your answers. You can either solve both equations for y, graph them and see where the lines intersect, or you can just plug -2 and -1 back in for x and y and make sure they work in both equations. So let's do that to check. So I'm going to store -2 for x and store -1 for y. If you hit alpha and then 1, that brings up y. Then I'm going to type in the two equations. The first one is 4x minus 3y. That equals -5, which is good. And then I have 3x minus y. And that also equals -5, which is what it should equal. So let's go ahead and take a look at some nonlinear systems of equations. We're still going to use substitution. So for this first example, we have y equals x squared minus x minus 6 and y minus 2x equals -2. Well, our first equation is already solved for y. So we can just go ahead and plug x squared minus x minus 6 in for y. And then the rest of the second equation is minus 2x equals -2. So now we have this quadratic that we need to solve. So you can either solve by factoring or by quadratic formula, by completing the square, whichever method you think is easiest. I'm going to solve this one by factoring. So I'm going to combine my like terms and set it equal to 0. Then I'm going to add 2 to both sides. So when I factor this, I need two numbers that multiply to -4 and add up to -3, which are -4 and 1. So then when I solve this, I get x equals 4 and x equals -1. I have two x values, which means I need to plug both of them in for x separately and get the y value for each of them. So I'm going to use my calculator to help me with that. I'm going to start with 4, store that for x, and then I'm going to type in the first equation because that's already solved for y. So if I have x squared minus x minus 6 and I'm plugging 4 into that, I end up with 6 as my y value. So then I can do the same thing with negative 1. Negative 1, store for x, and then if you scroll back up to the equation and hit enter, it'll bring it down for you. And you get negative 4 as your y value there. So again, you're going to write your answers as ordered pairs. So 4, 6 was one ordered pair, and negative 1, negative 4 was the other. So you have 2 answers for this one. And again, you can check these by graphing, or you can check them by plugging the numbers back in. I'm going to go ahead and check these by graphing, which we learned how to do last class. So I'm going to type the first equation into y1. And the second equation, if I solve it for y, I end up with 2x minus 2. So then I can go ahead and graph those. So I got my parabola and then my line. So I can check these 2 intersection points look about right. Negative 1, 1, 2, 3, negative 4, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. But again, you can check the exact roots by doing second trace and calculating the intersection points. The next system of equations is x squared plus y squared equals 25 and y equals x plus 1. So the second equation is already solved for y. So I'm going to go ahead and just plug that into the first equation for y. So I have x squared plus, then y is x plus 1 squared equals 25. So since we have x plus 1 squared, I'm going to do that work off to the side. So if I have x plus 1 squared, that means I have x plus 1 times x plus 1, and I need to double distribute. So I got x squared plus x plus 1, which is x squared plus 2x plus 1. So I'm going to use that in my equation. So I have x squared here plus that pink thing that we just multiplied out, so again, I'm going to solve this by factoring. If you prefer quadratic formula or completing the square, you can do that. If I combine my x squareds, I get 2x squared plus 2x. Then if I subtract 25 from both sides, I get minus 24 equals 0. So I can factor out a 2. And then I need 2 numbers that multiply to negative 12 and add up to positive 1, which are going to be x plus 4 and x minus 3. So my 2 x values are negative 4 and positive 3. Then, just like on the previous problem, I'm going to take my x values and plug them into the equation that's already solved for y. So if I plug negative 4 into x plus 1, I get that y is negative 3. And if I plug 3 in for x in x plus 1, I get that y is 4. So my final 2 answers are the ordered pairs 4, negative 3, and 3, 4. And again, you can check that either by plugging the numbers back into the equations or by graphing. But for this one, I would recommend plugging the numbers in because you have x squared plus y squared equals 25. So solving that so that you can plug it into the calculator is rather challenging. So I would recommend just plugging these numbers in for x and y. So let's go ahead and do that. So if I store negative 4 for x and negative 3 for y, And if I type in the first equation, x squared plus y squared, I get 25, which is great. Then if I plug the point into the second equation, if I do x plus 1, I get -3, which is the y value for that. Now I need to plug in the second point, so I store 3 for x and 4 for y. And then I can plug in x squared plus y squared again. That gives me 25, which is what I'm supposed to get. And then if I do x plus 1, I should get my y value, which is 4. So another way you might see these problems asked is you're given a system and it only asks for the x values. So that means you actually have less work to do. So both of these are already solved for y. So I'm going to take x squared minus 16 and plug it in for y in the other equation. And again, I'm going to choose to do this by factoring. So I'm going to move everything to the left side of the equation. If I add x squared, I end up with 2x squared. If I add 4x, I have plus 4x. And then if I subtract 14, I end up with minus 30. So I'm going to factor out a 2. Then I need to find two numbers that multiply to -15 and add up to 2, which are 5 and -3. So my x values are -5 and 3. Now, since both of these equations are already solved for y, I'm going to check this by graphing. So I'm going to go to y equals, clear my other equations, and type them both in. Then I'm going to graph. So you can see that they intersect at 2 points, and the x values are all that you care about. So you have -1, 2, 3, 4, 5, which is good, and 1, 2, 3. And you can double check those using the intersection function on your calculator if you need to. All right, this last question is actually the easiest. It says, is 2, 4 a solution to the system of equations? If it is a solution, then that means that the point 2, 4, so x is 2, y is 4, makes both of those equations true. So we can check that by hand, or we can do it on the calculator. So if I store 2 for x and 4 for y, so then if I type in x squared, I should get y, which is 4. So this point works in the first equation. And then if I type in the second equation, if it's a solution, it will also work in the second equation. And that gives me 8. So it does not work in the second equation, so this is not a solution to the system.